Alright, so in this video, I'm going to solve the equation 3 to the power of 3x minus 3 to the power of x is equal to 720. So, at first glance, this problem might actually seem a little difficult because we're dealing with a variable that is an exponent. Normally, x is a term like this, but this time it's an exponent, so that makes it a lot more difficult to solve. So obviously, I want to find the value of x. So for my solution, I'm going to first start with my equation here. So I have 3 to the power of 3x minus 3 to the power of x is equal to 720. And now I'm going to use the property a to the power of m times n is equal to a to the power of m to the power of n. So I'm going to use this property on 3 to the power of 3x to rewrite it as 3 to the power of x to the power of 3. So now I have 3 to the power of x to the power of 3 minus 3 to the power of x is equal to 720. Now from here, I'm going to let 3 to the power of x equal to the variable y. So this way, we don't have to really deal with it anymore because we're going to substitute in y for 3 to the power of x. And now, this makes this much more simple to solve. And then later, once we find the value of y, we can plug it back in here and then find the value of x. So our first goal is to find the value of y here. So now to do that, what I'm going to do is rewrite 720. So 720 is the same thing as 360 times 2. And 360 is the same thing as 180 times 2. So I have 180 times 2 times 2. And now this is the same thing as 90 times 2 times 2 times 2, which is the same thing as 45 times 2 times 2 times 2. So I have 2 to the power of 4 times 45, which is the same thing as 9 times 5. Now 9 is the same thing as 3 squared. So I have 2 to the power of 4 times 3 squared times 5. So (720) is equal to 9 to the power of 3 minus 9, because 9 to the power of 3 is 729, and 729 minus 9 is 720. And what I'm going to do now is plug this in for 720. So now I have y to the power of 3 minus y is equal to 9 to the power of 3 minus 9. Meaning I get y to the power of 3 minus 9 to the power of 3 minus 9 minus y plus 9 is equal to 0. And the reason I'm doing this is because notice now how we have a number to the power of 3 minus that same number to the power of 3. And then we just have those two same numbers but without being cubed. So now from here, I'm going to use the property a to the power of 3 minus b to the power of 3 is equal to a minus b times a squared plus ab plus b squared. So I get y minus 9 times y squared plus 9y plus 81. And now I have this minus y plus 9 is equal to 0. Now, negative y plus 9 I'm going to rewrite this as negative of y minus 9. And from here, I can factor out y minus 9 because notice how both these terms have y minus 9 in them. So I get y minus 9 times y squared plus 9y plus 81 minus 1. So this turns into y minus 9 times y squared plus 9y plus 80. So now this gives me two equations. I have y minus 9 is equal to 0, and I also have y squared plus 9y plus 80 is equal to 0. So for y minus 9 equals 0, all I have to do is add 9 on both sides, and I get that y is equal to 9. Now for y squared plus 9y plus 80 equals 0, to solve this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 9, and c is 80. So I get y is equal to negative 9 plus or minus the square root of 9 squared, which is 81, minus 4 times a, which is 1, times c, which is 80, all over 2a, so 2 times 1. Now this turns into negative 9 plus or minus the square root of 81 minus 320 over 2, which is equal to negative 9 plus or minus the square root of negative 239. Now, 239 what I'm going to do is I'm going to simplify this, the square root of negative 239. So 239 is a prime number. So what I'm going to do is rewrite this as the square root of 239 times the square root of negative 1 over 2. And the square root of negative 1 is equal to the imaginary number I. So I get negative 9 plus or minus the square root of 239 I over 2. Now that we have our values of y, I'm going to go back, and remember, 3 to the power of x is equal to y. So I have 3 to the power of x is equal to 9, meaning x is equal to 2. So this is one solution. And I have 3 to the power of x is equal to negative 9 plus the square root of 239i over 2, and negative 9 minus the square root of 239 over 2. But you can't take the power of a positive number and make it equal to a value of I, because that's an imaginary number. Meaning there's no solution for these values of y, and our only solution is x equals 2. Alright, so in this problem, I have 9 to the power of x plus 15 to the power of x is equal to 25 to the power of x. So I'm going to first start by dividing both sides by 9 to the power of x. So now this results in 9 to the power of x over 9 to the power of x plus 15 to the power of x over 9 to the power of x is equal to 25 to the power of x over 9 to the power of x. Now 9 to the power of x and 9 to the power of x cancel out. So I get 1 plus 15 to the power of x over 9 to the power of x is equal to 25 to the power of x over 9 to the power of x. Now, if I have something in the form a to the power of m over b to the power of m, this is the same thing as a over b to the power of m. So 15 to the power of x over 9 to the power of x, that's going to equal 15 over 9 to the power of x. And 25 to the power of x over 9 to the power of x, that's going to equal 25 over 9 to the power of x. And now, 15 over 9 simplifies to 5 over 3. And 25 over 9, that simplifies to 5 squared over 3 squared. So now 5 squared over 3 squared, that's going to equal 5 over 3 squared. Now I have this to the power of x. Now if I have something from a to the power of m to the power of n, same thing as a to the power of n to the power of m. So 5 over 3 squared to the power of x, that's the same thing as 5 over 3 to the power of x squared. Now I'm going to let 5 over 3 to the power of x equal to the variable y. So I get 1 plus y is equal to y squared. And if I subtract y and 1 on both sides, I get y squared minus y minus 1 is equal to 0. So I get a quadratic equation, and to solve this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I get y is equal to negative of negative 1 plus or minus the square root of b squared, which is negative 1 squared, minus 4 times a times c, which is negative 1, all over 2a, so 2 times 1. This is equal to 1 plus or minus the square root of negative 1 squared, which is 1, minus 4 times 1 times negative 1, which is plus 4, all over 2, which is equal to 1 plus or minus the square root of 5 over 2. Now remember how we let 5 over 3 to the power of x equal to y. So I have 5 over 3 to the power of x equals to 1 plus or minus the square root of 5 over 2. So now this gives me two equations. I have 5 over 3 to the power of x is equal to 1 plus the square root of 5 over 2, and 5 over 3 to the power of x is equal to 1 minus the square root of 5 over 2. So 5 over 3 to the power of x equals 1 minus the square root of 5 over 2. Well, 1 minus the square root of 5, that's going to be a negative number. And a negative number divided by 2 is still a negative number. And notice how we have a positive number to the power of another number here. And you can't take the power of a positive number and make it equal to negative, so there's no solution for this. Now for 5 over 3 to the power of x is equal to 1 plus the square root of 5 over 2. To solve this, I'm going to first start by taking the log on both sides. So I have log 5 over 3 to the power of x is equal to log 1 plus the square root of 5 over 2. And if I have something in the form log a to the power of b, I can move b to the front, so it's going to equal b times log a. So in this case, I have log 5 over 3 to the power of x, and I can move x to the front, so I get x times log 5 over 3 is equal to log 1 plus the square root of 5 over 2. Now if I divide both sides by log 5 over 3, these two cancel out, and I get x is equal to log 1 plus the square root of 5 over 2 over log 5 over 3.